help them extract these variables from judgments. It's not clear here, but for example, there one variable of interest is the age of the victim. She's a 16-year-old daughter who was the victim in that particular case, but the researchers wanted to know the age of the victim. It was not available on metadata, but we wanted to extract. Just wanted to share one research report that was done. Your old daughter's say in that, because she's a minor. So there were cases where POCSO was misused that way to criminalize love affairs between adolescents. And how do we test this hypothesis? Similar approach was done. We took all the POCSO cases. They took all the POCSO cases and saw this word repetition of the word love in the judgment, because judgments in India are very elaborate. Judges write every thing that is being discussed in the court. So we just tried to extract the word love in the judgments, and then found that, okay, how many cases are there where the case is registered only because it is a love affair that is being discussed, but not any significant crime, because in most of these cases there is no punishment. Judge eventually recognizes that this is a fake case, and he would not consider the case. So that is one of the use cases, and there it was a simple regular expression search that we have done. We have just taken a judgment and saw the presence of word called love. But now we wanted to do something more detailed. There were many more variables that we wanted to pick from each judgment, and I'll show you a few of them. So what are regular expressions is one way in which we try to extract variables, because it's still context-based models we wanted to use, but there are not enough open source models that are trained on Indian judgments to understand Indian judgment, because Indian English is different, but Indian legal English is even more different. So we were not able to use a model that was trained on general English on India's court judgments, because there were a lot of errors. So regular expression is one thing we still try to use, at least in those states where judgments are a little standardized. For example, we chose the states of Assam, Tamil Nadu, and Maharashtra, where we found that at least within the state, there are the judgments are more or less, they have some kind of a format. So for each state, we wrote a code to find out using regular expressions to extract the variables of our interest. So regular expressions is our workhorse. We use them a lot to get a lot of variables of our interest. But then one important NLP model that we used is called OpenAI. This is an open source NLP model developed by a bunch of organizations in Bangalore, and it is very helpful. So they have two NLP modules basically. People I can go into depth into those two modules, but basically one is a named entity recognition, which means they trained the model is trained on Indian court judgments, so it is working well on Indian judgments. It can pick out up to 14 variables of interest, and these 14 variables could be statutes in a given judgment. So for example, in our judgment, we wanted to know which particular statute of POCSO, section of POCSO was used in this particular case. Is it section, I think in here, it was section 4 of POCSO Act. So researchers wanted to know which section was used in that particular act, in that particular judgment. So it was hard to use regular expressions to pick out statutes, because courts write these judgments in act names in various formats. Sometimes it's written in the full form. It is written as the protection of children against sexual offences. Sometimes they just write it as POCSO. Sometimes they just write it as the act somewhere in the middle of the judgment because they referenced it somewhere else. OpenAI did a very good job of they trained on a lot of judgments, so we were able to extract all POCSO and every statute, POCSO, IPC, and whatever statutes that are mentioned in the judgment. We were able to extract each of those judgments for each case, each of those acts for each case. And we also tried to use ChatGPT limitedly, but again, we were also concerned about the privacy issues involved with it, because these cases are very, they include private information of a lot of citizens, and there were concerns that ChatGPT stores the information, and also we didn't want to. We just did a pilot project testing out how good ChatGPT is working to give us the variables of our interest, but mostly we had worked on regular expressions in OpenAI. And yeah, so right now our application of this data set is more into policy reforms. Now we are writing a report of it to understand child rights ecosystem in India. But the applications are immense. Once we get these data sets on any particular theme, like for example, I was reached out recently to just understand what kind of books are banned by example. You can take one particular act, say I think a UAPA act or some act that is deals with banning of books, or they will arrest you if you possess certain kinds of books. So you can focus on one particular act, go to the e-courts website, or get those judgments where this particular act was used, and then run a regular expression or OpenAI sort of algorithm to extract what those books are. And that will give you a good sense of, okay, what are those books that the government wants you to read and doesn't want you to read. So many use cases like this. There are legal tech applications, there are academic studies that are being done using this. And we do run something called data dialogues every month or so, where we try to talk to a lot of people who work in this intersection who are using data to understand judiciary better. And we run a lot of webinars that way just to understand how this intersection is being used in India. So we ran a small experiment on POCSO Act. There are 4 legislations related to child rights in India. POCSO is just one of it. We had some experience working with POCSO for a couple of years now. So we wanted to try doing this OpenAI experiment on POCSO first before going to anything else. What we did, in the state of Assam, we took a good sample of 51 judgments that are again across a few districts where there is some standardization in the way judgments are delivered. So we took those 51 judgments and then wrote our logics to extract these variables using regular expressions and OpenAI. And again, this is a pilot project. We just wanted to see if there are in a judgment. I'll just tell you how a judgment is delivered. When a judge delivers the judgment, there are few relevant sections under which the case belongs to, but the judge also recalls a lot of other judgments like precedents and all. Like for example, a crime was committed in which the relevant section is section 4 of POCSO, but the judge goes on delivering the judgment and somewhere he says that, in some other case 2 years ago, section 3 of POCSO was also used. Section 3 of POCSO is not relevant to this particular case, but it is there in the judgment. So if we initially OpenAI was picking up section 3 also, and it is saying that it was the relevant section for that particular act, for that particular judgment, but our researchers said that no, that is not part of that. Your model should not pick section 3 because it is present not in the relevant section. It is a wrong data basically, it's a false positive. So we ran a model, made few tweaks to the OpenAI, like we downloaded the OpenAI model, made a few tweaks to it, and then tried to identify those relevant sections in each judgment. And we also compared it with the metadata, because in the metadata also there is one row available which says that what is the mean. This is something called principal offense. For every case in India, there is something called a principal offense. Principal offenses, you can consider it as a major offense in that particular case. For example, I beat someone and then later I also kill someone. The principal offense is that I killed someone, not just beating. Beating is also a case. The researchers want that, I have beat him and then murdered him. But the metadata is only capturing the principal offense. But the judgment would capture all the offenses that I have committed. And the researchers wanted to capture all the offenses because that will also give a sense of how offenses escalate. And that is helpful in a lot of, especially in sexual offenses also, because there is a trajectory to how the principal offense is committed. And if you can stop the offense at the initial stage itself, then probably you will avoid those principal offenses. But again, metadata was not capturing all the offenses, it was capturing only the principal offense. So we wanted to get all the offenses that were involved in a particular judgment. And we compared the data that we extracted with the data that is on metadata. And we found that except for the 3, I think in 3 judgments, there are complete data entry mistakes in metadata itself. It was nowhere available in the judgment, but it was available on metadata, which is a matter of concern because people are using metadata for any analysis that could be wrong. And then there are, for 28 judgments, it was decently captured, but for other judgments, again, metadata was not very exhaustive. It was like our model was able to pick more judgments that are relevant to the case, which was not on metadata. So that was a small experiment that we have done. It gave us enough confidence to go ahead. And now I've written a detailed blog about it. So I am happy to share that. So these are the screenshots, but it's not very visible. I will just tell how OpenAI works. So, okay. So OpenAI again, there are it has two basic modules. One is a named entity recognition, and if you can see on the screen there, in a particular judgment, it is able to identify what is the name of the court, what is the name of the judge, petitioner, respondent. These may not be of great interest, but the variables that were of very interest to us are provision and statute, because that was what we used to identify those relevant sections in each judgment. And then the other part, which was very important in OpenAI model we used was, there is an extractive summarization module. There are two kinds of summarization in general. There is an abstractive summarization and an extractive summarization. Abstractive means like I'm saying something right now, you go home and you tell your friends what I have said. And it will not be in exact words that I have told, right? You would synthesize something and you tell it to your friends. That is abstractive summarization. But in extractive summarization, you use the exact words. Probably I repeated a lot of sentences. You think that those sentences are not needed, so you cut them down. When you only use those sentences that I used that are relevant to the talk. So OpenAI does this. It provides an extractive summary of each judgment. They divide the summary into 5 types. It's called PHYLAC in legal studies. It's called PHYLAC summary. There is one summary which gives facts of the case. There is one summary which gives analysis of the case, all laws involved, analysis, and then a decision part of the summary, like what is the final decision that the judge has delivered. So few of those, these summaries were helpful because we only wanted what, for example, when we wanted to identify which offense was committed, we directly went to the only decision part of the summary and only saw which statute was mentioned in the decision. That way we avoided all those other sections that the judge probably mentioned when he was delivering the judgment. So this was our data model in a sense, like this is how we did our project. Again, Indian, like when we were getting the judgments from eCourt's website, most of the PDFs are not machine readable, the scan copies. So we had to do some we use PyTesseract on Python. Again, it is also open source. So we use that, the scripts are there. We use that to convert each of the PDFs to a machine readable text format, and OpenAI takes input in a TXT format. So we perform named entity recognition directly also, and then we use these as extractive summarization modules, find the summaries that we want, and within the summaries, again, we look for the variables using regular expressions. And finally, now, currently the project is at a stage where there are interns who are now validating the model results. And we hear that, we have worked on 300 judgments so far, and across 3 states. There are 2 parts of the project. There is one metadata analysis where we are completely, there are about 90,000 cases related to child rights in India. And for metadata analysis, we are taking the metadata that is available on eCourts, and all 90,000 cases are being analyzed with respect to that. But we took a small sample of about 300 judgments, and for that we are doing more detailed judgment analysis. That's what we are calling. And based on this, there are a few use cases that we wanted to do, like if we gain more confidence about extracting variables through this approach. One thing is eCourts can directly use it. eCourts, if it can update their metadata, instead of, I think currently it is being done manually, but if they can use some approach like this to produce metadata, it can be much more exhaustive and will be much more useful, and we don't have to do this if they do it. So that is one good use case that we can think about. Otherwise, in general, also for any empirical legal research, we are seeing a good buy-in now to use these models for research. And yeah, few challenges I mentioned are: one, we are only limited to English judgments that are delivered in the country. For Indian languages, we are looking forward to the Bashini model, which is another NLP model championed by the government of India. And there is in IIT Madras, there is an AI for Bharat initiative where they are trying to develop an Indic NLP library, which helps in machine translation of Indian languages between English and Indian languages. So we are looking forward to how we can use Indian judgments also, because a lot of district court judgments are actually in local languages. Right now we are again limited to only these few states, because only in these states district courts deliver English judgments. Context-based language models is something we want to use. Right now, OpenAI we are using, but when we started the project, ChatGPT did not come out yet. Like I think 2 months after the project, ChatGPT came out, but again we had concerns with using ChatGPT as well. But there are other context-based models that we discussed that we got to know later on. For example, like you just give a piece of text and ask a question. What is the capital of Germany? For that piece of text, and the model will be able to answer give a good answer. So we tried to do this. We gave the judgment and asked, what is, and then asked what is the age of the victim. Model was answering, but we are not sure about the accuracy yet. So those are few experiments that we are yet to do and we want to do. And lack of standards in Indian judgments. Only few states, at least I think Andhra Pradesh, Telangana, Assam, Maharashtra, there are few states where at least within the state there is a standard in which the judgments are delivered, but otherwise there are differences across district courts as well, and across different types of courts in the way judgments are delivered. So that was also a little challenge, because we had to write a code again and again because of this. So yeah, that's it. And Justice Hub is an initiative, and we will put all our data sets on Justice Hub once they are finalized, vetted and reviewed. Codes will also be available, everything over there. So you can follow us over there or ask questions.
Thank you, Sai Krishna. Yeah, we have a few minutes for questions if anybody has questions.
I was just asking if you publish all your analysis that you're doing in the Justice Hub.
Yes, everything will be on this. So right now we are in that phase where the data sets are there. Now our research partners are writing reports.
So do you face any legal issues if you're, basically creating analysis related to a lot of sensitive issues and sensitive documents, right? So if you create analysis that, probably that is against some big parties like maybe governments or which basically portrays that maybe government is filing such cases across like multiple governments, not just the current one, but yeah, overall if you're publishing some of these research analysis on your site, do you foresee any threats to you in terms of legal issues that you
So one of the cases Civic Data Lab has worked on, Justice Hub has worked on previously, is the along with Internet Freedom Foundation, we have worked on Zombie Tracker, which is the use of section 66A, if I'm not wrong. So misuse of 66A even after it has died. So obviously in such cases, I don't think I've heard any story of backlash from the government or something, because mostly we are working with open data, where whatever data is available on in public, we are using that, just doing some sort of using tools like this to extract data sets from it and do analysis. So yeah, I have not heard of any story so far that got a major backlash, but there were, I think I've seen some few people use Twitter just to say that they tagged us and say they're doing anti-national work and all. So except for that, I didn't see anything major. Yeah.
Okay, thank you.
Yeah.
Hi, you mentioned about extracting the data from PDF, which is in the scanned form, right? Are you able to hear me?
Sorry, not audible.
Hello? Is it audible? Okay. So what I'm saying, you mentioned this judgments are in the scanned form in PDF. So would you please elaborate how you extracted the data from the scanned PDF?
Yeah. So we have a script for it. So basically, Google has this Tesseract module which is used for OCR. Basically, it's a OCR, optical character recognition, that is at play. So we take each, basically we are dealing with images right now, not PDF pages. So we take each page, use OCR to take the text from the page and then save it as a, like, so we take each page and then save it in a text and keep appending it. So that is the simplest thing I can tell right now, but yeah.
Yeah, actually, similar kind of thing I have used. IBM has a tool, I don't remember, but I have used that one. So that is actually like read the scanned PDFs and store. It converts into structured format and the storage in the DB. So I don't remember so that's what I was thinking that whether.
Again, there are challenges right now. Even if in the PDF that we are working, even if there is a table, we ignore the table because there are very few judgments where there is a table. So our code will still pick the text from the table, but it won't be in the table format. It will just pick all the text from the image and put it in a text file. So we don't know if it is part of a table or not. For tables, I'm not sure. There are other modules again, there were a few modules that pick only tables from these images. So for our use case, we were happy with just picking whatever text is available in a particular photo.
So it's Python script or?
It's a Python script.
Okay, thank you.